your map, your friends, your social media feed, all connected. But have you ever wondered how Google Maps finds the best route or how Facebook suggests friends? The secret lies in graphs. A graph is a way to represent relationships between objects. It's made up of nodes, or vertices, and edges that connect them. In real life, think of nodes like cities and edges like roads. When you search for directions on Google Maps, it's essentially finding the best path between two nodes. Similarly, on social media, nodes are people, and edges are friendships or connections. There are two main types of graphs, directed and undirected. Directed graphs have edges with direction, representing one-way relationships. For example, on Twitter, you follow someone, but they might not follow you back. Undirected graphs, on the other hand, have edges without direction, representing two-way relationships. Road networks are a great example, where roads connect cities in both directions. Let's dive deeper into graph terminology. A node, or vertex, is a point in the graph. An edge is a connection between two nodes. When two nodes are connected by an edge, they're called neighbors. The degree of a node is the number of edges connected to it. Think of it like a party. Each person is a node, and when two people shake hands, that's an edge. If someone has many friends at the party, their degree is high. Graphs aren't just theoretical, they're used in many real-world applications. Google Maps uses graphs to find the best route between 2 points. Social media platforms use graphs to suggest friends or content. Network topology uses graphs to visualize computer networks. Even recommendation systems, like those on Netflix, use graphs to suggest movies or shows. Graph algorithms are used to traverse and analyze graphs. One popular algorithm is breadth first search, BFS. BFS starts at a given node and explores all its neighbors before moving on to the next level. It's like exploring a city block by block. While graphs are powerful, they also come with challenges. As the number of nodes and edges grows, scalability becomes an issue. Data sparsity occurs when there are many nodes but few connections. Complexity arises when dealing with large, complex graphs. Graphs have many practical applications. On social media, graphs help with friend suggestions and content recommendation. On Google Maps, graphs optimize routes and predict traffic. In conclusion, graphs are a fundamental data structure that represents relationships between objects. They're used in many applications, from Google Maps to social media. Understanding graphs can help you analyze and solve complex problems. Next, we'll explore how to find the fastest path using graph algorithms. Thanks for watching.